Hi, thanks for listening today. My name is Josh Miller and I'm the Operations Director at StackRack. Today I'm going to talk about StackRack's residential product line and I'll go over our new battery modules and cabinets and show you how you can use these products to design customized battery system for just about any residential product. I'll also be going over some industry net metering trends, some installation setups for our systems, along with different solar and storage scenarios for different homeowners. So, with that, let's get started. Company overview. At StackRack, we build modular battery systems for residential, commercial, and utility scale projects. We are one of the few manufacturers who offer complete battery systems for all three energy sectors. We're here to assist you on your projects. We're service oriented. We help with system design, battery sizing, single line diagram review, engineering. We've been in the industry for over 30 years. We've been involved in small residential systems all the way up to large megawatt utility projects. We have over 14 patent pending on different manufacturing and assembly processes. StackRack was formed over 4 years ago with the goal of developing battery systems just like the ones I'm going to show you today. Systems that are modular, simple to install and customize. And we're excited about the response we've received so far from the industry, along with our installation partners. We're growing and we're excited about the future. When we started out designing our residential lineup, we recognized that every home uses energy differently. Every installation, every project is unique. Some homes use more than average energy. They'd probably benefit from a larger battery bank. Some homes have unique installation requirements. They have limited space. The list goes on, but you get the point. There's no one size fits all battery system for every home. So we wanted this system to be unique in the fact that it's modular, expandable, very simple to install, while also adaptable to meet the unique installation and permit requirements for different homes, cities, counties, states, and climates. So we started with the battery, and this is our SR5K UL battery module. It has some very advanced features. It's a 5 kilowatt hour module with a very compact rack mount design. We then worked with solar installers in the industry to design different battery cabinets that would help provide solutions for unique installation challenges that are occurring every day. And what this means for our installation partners is you can get comfortable and trusting with one battery module, our SR5K battery module, and then you can use these plug and play pre-assembled battery cabinets to use in different residential applications to solve just about any residential project. Highlighting what this system can provide. On the right-hand side, you get flexible battery sizing in 5 kilowatt hour increments. This is a plug and play installation architecture. The battery cabinets are pre-assembled. It's very simple to slide modules in. It's simple to expand battery banks. You can add battery modules at any time. It's very simple to connect battery cabinets to one another through the bus bar system. The ability to choose which cabinet you need for which project and the number of batteries lets you help reduce overall system costs. All of our battery cabinets, except for the SR brackets, are outdoor rated. And then I'll talk about this in just a few minutes. I have some dedicated slides for this, but some really advanced programming that you can do with the Luxpower inverters for time of use, for peak shaving, self-consumption, etc. So taking a look now at our SR5K UL battery module, this is a 5 kilowatt hour rack mount battery, and it has all the advanced features you're going to be looking for in a premium battery. We use tier 1 prismatic cells, lithium iron phosphate. We have integrated fire arresters, pre-charge resistors. There's Amphenol connectors for easy connection of battery cables. The BMS allows up to 64 battery modules to communicate together for a total of 320 kilowatt hours. There's integrated battery heaters to automatically warm the battery cells during extreme cold climates. There's closed loop communication with the industry leading inverters from Luxpower to Solarc to Victron. And there's an integrated LCD screen for simple battery monitoring and BMS programming. The battery module is UL 1973, UL 9540A certified, SGIP and CPUC listed. We offer a 10-year, 6,000 cycle warranty, as well as an optional 15-year extended warranty. Moving on now to the Luxpower 12K inverter. This is really a Swiss Army knife hybrid inverter that we use for residential and light commercial. Some of the features that this inverter offers, a color touch LCD screen, which makes programming and monitoring very simple. There's an integrated 200 amp transfer switch less than 10 milliseconds. You can parallel multiple units together for larger power outputs. There's integrated load and battery breakers, which help reduce on balance of system costs. There's 3 MPPTs that you can allow up to 18 kW of DC coupled solar. There's an extra large conduit box, which makes installation of these large gauge wires very simple. There's a generator port for 90 amp AC coupling. You can also use this port for smart load. You can also connect an auto start generator. There's 12 kilowatts of continuous output, which is amongst the highest in the industry. And then the feature that is really changing the way installers are using this inverter is the 200 amp pass through. I'll show you in just a slide, in a few slides, of how this inverter and this feature allows installations to happen for whole home backup without including a critical loads panel. This is the LCD screen on the Luxpower 12K. The layout's very simple. It's very easy to see how energy is flowing from solar and battery and grid. I also think they've done a really nice job from the menu standpoint, putting different settings that are very simple to follow. You can get into data settings and you can see active communication with the batteries, state of charge, energy flow, all important data. This slide highlights what the web portal and the web app will provide you in terms of data. Again, a really nice layout showing you how energy is going to be flowing. On the web portal, there is an integration with Tigo optimizers. So if a homeowner has a Tigo premium account, they can link their Tigo monitoring to the Luxpower portal, and they can see both their solar panels and their energy system all in one place. And a feature that we're going to be rolling out very soon is the ability to not only monitor solar panels, but to monitor each battery within the portal as well. So you'll be able to see overall system energy flow along with state of charge, voltage, current for each battery, or you'll be able to monitor all solar panels if you're using Tigo optimizers. This gives you an overview of the 4 different rack and cabinet options for our residential systems. All of these products use galvanized steel with UV resistant powder coated finish. The SRB2, SRB4, and SRB6 cabinets are outdoor rated. Okay, now let's talk about some trends in the residential solar and battery storage industry. Now, the top left graph in blue is a typical home load profile. You're seeing the largest peak in the evenings when load demand is the highest. Superimposed on top of that graph is the recent data out of California showing a very sunny, cool day, typically in the month of March or April. And the take-home message out of this graph is that solar available on the grid in March and April is causing electricity prices sometimes to go negative because there's so much available that California is sometimes having to clip the available solar energy. But then in the evening times when people are coming home, the demand on the grid goes up drastically. And it's data like this that really made California make the changes that it did regarding net metering 3, with the 2 biggest changes being ongoing time of use rate plans, which are going to cost more when energy demand is higher in the evenings, and then avoided cost rates, which now compensates exported solar based on the price that the utility company would either buy it for on the open market or the cost that they would incur to make the energy themselves. Now, the bottom left graph is showing active policy changes regarding net metering across the country. And the trends that we're seeing are other states are following suit to California, just maybe not as drastic at this point in time. So when we look at these policy changes and we discuss systems actively with installers, we're seeing some very common trends. The first being is that solar still makes a lot of sense for the vast majority of homeowners. And in order to size solar systems appropriately to really take into effect the average daily consumption that homes are using, you really have to have larger battery systems to accommodate for more solar panels on the roof. Because at the end of the day, you are trying not to export any of the additional energy that you're making from your solar system because you're not getting compensated very well for it. Now, this leads into point number 2, whereas if you're making your own energy through solar and storing it in your own batteries, then you're reducing the overall energy that you're utilizing from the grid. And that's going to help reduce things like non-bypassable charges and mitigate time of use plans, and also help insulate customers from increased rates. And then finally, time will tell, but for some customers, it'll ultimately make sense to really just reduce and go off grid altogether. In Hawaii, you see things like grid connection fees that are occurring on a monthly basis. There's ideas that have floated for monthly charges in California. And at some point, if the rates continue to increase at the way they have been the last 25 years, for some customers, it just might make sense to turn your home into a microgrid and turn the grid into your last resort standby generator. So, one of the ways that you can use your battery system to help reduce your electric cost is by selling back to the grid and avoiding the expensive time of use rates, which are typically in the evening times. And I'll talk about that in just a second. But before I do, let me talk about the economics of solar and battery storage. So, when you consider the cost per kilowatt hour of a solar system over the lifetime of that system, some estimates have it as low as 4 to 5%, but using just this calculation down below, I have it set towards 6 cents per kilowatt hour. And if you do some of the same calculations for a battery system, taking into consideration depth of discharge, round trip efficiency, and total kilowatt hours stored and discharged over the lifetime of the battery, then the cost of that battery system can be down to 15 cents a kilowatt hour. So when you combine solar and battery storage, and I've tried to be conservative here, I have it as low as 21 cents a kilowatt hour. Now, if the cost for solar installation and the cost of the battery is less, then that price is going to go down. And if it's more, then it's going to go up. But for the purposes of this graph, let's just say it's 21 cents a kilowatt hour. Now, on the left-hand side, you have a typical time of use plan from Southern California Edison. You're seeing mid peak at 28 cents. You're seeing on peak in the evenings as high as 51 cents, which correlates to the demand, which is highest at home. On the right side, you're seeing what can happen with battery storage with solar, where during the day, the energy could be powered by solar, which would equate to 6 cents per kilowatt hour. But then in the evenings, as the battery is charged and starting to utilize some of that energy, then the cost per kilowatt hour is 21 cents. And based on the size of your battery bank, you can program the system to discharge more than what you're using during that time. And based on avoided cost rates, you can actually get more credit because that's when the utility company would utilize this energy more. And then when your battery is depleted, you'll go back to using mid-peak pricing, which is 28 cents a kilowatt hour, and the cycle repeats itself. Based on the size of your solar and the size of your battery, this bill credits would depend on how much energy you're discharging or how much energy you're using during the evening times, would be how well your return on investment and your overall savings would be. Now, this is how peak sellback would look like in 5 years if energy prices have increased on average 3% per year, which they have for the past 25 years. You're seeing the mid-peak pricing being higher at 32 cents. You're seeing the on-peak pricing as high as 57 cents. This is what it would look like in 10 years following the same trend, and then 15 years from now. So now I'll highlight a couple of key points. You'll notice that the solar and the battery price per kilowatt hour stays the same compared to what it was 15 years ago. The part that's a little unknown is how California and other states that are using avoided cost rates are going to compensate you or other customers in the future. What I mean by that is they need the energy now. They're offering higher rates for that kilowatt hour now, but will that change 5 years from now, 10 years from now, 15 years from now? We don't know. Would this go away with net metering 4 or net metering 5? We don't know. With the adoption of electric vehicles and the drastic need for battery storage on the grid, it makes sense that this would still be here, but these are variables that we're just not sure about. Now, let's look at a different way to use your battery system, which is self-consumption. In a self-consumption model, you're storing and using your energy and you're limiting how much you sell back to the grid. We generally like this model more than peak shaving or peak sellback because you have more control over your energy and there's less variables related to policy and utility company export rates and net metering changes, et cetera. And when you look at the fact that an average home uses 30 kilowatt hours a day, and based on where they're located in the United States, 4 to 5 peak sun hours a day, if a home gets a 7 to 10 kilowatt hour solar system along with a 30 kilowatt battery system, we're finding that homes can reduce their grid use by 85 to 90%. And what I have shown here in the top right corner is our Power Station Pro, which it has been designed exactly for that purpose. Using this hybrid inverter, this all-in-one setup, along with 30 kilowatt hours of battery storage, this single unit can convert the home into a microgrid, in which case you're only using the grid for power when your battery and your storage is not sufficient enough. And when you look at the economics of this over a day by day basis compared to where time of use rates are, this can have a real profound effect over time, 5, 10, 15 years in the future, because you're creating, you're generating, you're storing, you're using your own energy, which you control. So in this setup, you not only get whole home backup, you get really grid independence and insulation, avoidance of rate hikes, net export policy changes, non-bypassable charges. But at the same time, using the same equipment, at any point in time, you can change the programming in these settings to switch to peak sellback or do a little blend of both. Really, it comes down to what you want to do and what works best for you. Now let's look at a diagram showing whole home backup using the Luxpower 12K without a subpanel. And this setup utilizes the 200 amp grid pass-through feature. This setup is very popular because it can drastically reduce installation time and cost because you're not having to rewire that main panel into a subpanel. Now, if you're looking at this diagram and you're wondering, how is this going to meet code compliance for safety and rapid shutdown? The way this works is by having an emergency stop mushroom button, the 200 amp fuse disconnect, and the main breaker in the main panel. By pushing the emergency stop button, you will not only shut down the inverter, but also the batteries. You'll also turn off the panels by doing so. You'll cut the AC output from the inverter to the main panel. By turning the 200 amp fuse disconnect off, this will cut grid energy from the main meter to the inverter. You turn off the main breaker to the panel, and this will cut all circuits to the home. Now, if you're also wondering, how do I do load shaving or load management in this setup if I don't have a sub panel? And a common way of doing this is by using the generator port and triggering the smart loads feature of the inverter. And then you can move loads over here like large air conditioners or even EV chargers that you would want to be ordinarily turned off in a grid outage. And then by programming the inverter, that sub panel would automatically be de-energized in a grid outage. Moving on to whole home backup with a sub panel, this is more of the traditional way of doing essential loads or whole home backup with battery systems. One thing I'll point out with this inverter is how you place the CT sensors in this setup will have an effect on how the inverter works. So if you put the CT sensors on the grid lines inside the inverter, as opposed to putting them on the main lugs of the main panel, then any loads that are on the main panel will just be powered by grid energy. If you put the CT sensors on the main lugs of the main panel, then the inverter will not only power the loads into the subpanel, but it will actively try to discharge battery power to backfeed into the main panel and try to zero out what the main panel is using. So that setup with the CT sensors on the main lugs and using a subpanel is another way of load shedding in the event of a grid outage, meaning that grid goes down, the main panel is going to be de-energized, sub panel is going to continue to get powered by the inverter. And ultimately, this may be the only way to permit this system with some AHJs in cities allow. This diagram is showing another way to use battery systems for homes that aren't concerned about whole home backup. They're really concerned about still taking advantage of self-consumption and trying to minimize energy they're using from the grid to reduce their electric bill. But if the grid goes down, they're not concerned about it, or they have so infrequent grid outages that it's not a priority for them. And in this case, you're wiring the inverter very similar to a traditional grid-tied inverter, where grid lines are going to be coming from the main panel into the inverter, and there's really no circuits connected to the load output. And then by using the CT sensors on the main lugs in the main panel, the inverter will actively backfeed into the main panel to try to zero out what the home is using. And based on the size of the solar and the battery system, you can still achieve 80, 95% of self-consumption by doing this method. And then the last diagram that I'll show you here is a common question we receive from customers and installers is what simple way to add battery storage to existing solar systems? And this inverter makes it very simple by using the generator port for AC coupling. Any inverter that's 1741 listed, you can just take the connection points into the main panel and redirect them into the generator port of the inverter. And then again, based on the different diagrams we just talked about and what the customer's goals are, you can do whole home backup. You can do backfeeding into the panel for self-consumption. And the added benefit of this setup is with the equipment that's already there with the Lux inverter, you can add at any point in time up to 18K of additional DC coupled solar without modifying or changing the existing solar system at all. So, talking now about our Power Station Pro. When we first designed this system, we wanted to think outside the box in terms of making a system that was all in one, simple to install, simple to expand, and really reduce the complexity of installations from project to project to project. And when you look at Power Station Pro, we have the ability of providing and controlling everything inside the cabinet. When this shows up at a job site, it doesn't matter if the home is big or small, everything inside the cabinet can be the same. The only variable is going to be how long or how many conduit runs need to be made from the main panel to the disconnect switches based on where that installation is going to be and where the equipment is. So what that means from an installation standpoint is once you've installed Power Station Pro 1, 2, 3 times, you can become very familiar with the steps, and this can help really reduce installation time and complexity. Furthermore, we provide all battery cables, ground and communication cables, conduit box, inverter, hardware for this unit. And this unit can be placed on a concrete slab, on a generator pad. It takes up a very small footprint. So now talking about some of the features that make Power Station Pro really special. Multiple knockouts along the top conduit box for lots of flexibility for installation and connections. The ability to mount the Luxpower inverter directly on the side of the cabinet. The ability to put the outdoor rated conduit box on the side of the cabinet and have a connection from the inverter using bushings that are provided into the cabinet, so battery cables and wires can travel within the inverter into the cabinet without any additional conduit. On the top of the cabinet, the roof can be removed, and that gives you access to the bus bars. And for paralleling different cabinets together, you have dual side entry doors, which allows you to orient the cabinet either way based on what's best for the inverter and the setup. There's lockable doors, and there's temperature controlled cooling fans to maintain optimal temperature inside the cabinet. We have industrial bus bars in the top of the cabinet up to 1,000 amps. This really comes into play for light commercial or larger homes where you want to parallel multiple cabinets together and use multiple inverters. There's options for remote monitoring, Wi-Fi, and 4G dongles. The outdoor rated conduit box allows for gridded load lines to easily come in and attach. From the battery side, there's mounting holes to allow you to slide the batteries in and secure them very simply with the hardware that's provided. All the cables are provided, so there's no guesswork in terms of crimping or ring terminals or how long the cables need to be. And then the closed loop communication between the batteries, BMS, and the inverter really creates this fully integrated system with tons of flexibility and options. Now, an optional feature which is unique to Power Station Pro on a residential level, you'll see this on some commercial systems, is the ability to add a 500-watt air conditioning heating unit. This increases the scope of how you can use this system for really hot or really cold climates. The unit comes with integrated Freon, would turn on at certain temperatures, keep the battery cabinet at optimal temperature. And then when it's within the optimal range, it still circulates air, but it does so in a closed system. Let's talk now about battery solutions for NFPA 855 and 2024 IFC. And this comes into play in certain installations where certain HJs or cities just don't want more than 20 kilowatt hours in a single enclosure, or if the project or installation has very minimal setbacks, and you're trying to get these systems on the wall or reduce the amount of exposure off the wall as much as possible. And in these situations, that's where the SRB2 and the SRB4 really come into play. These are cabinets that are both outdoor rated. You can mount these on the wall or place these on the floor. And both cabinets are less than 11 inches in depth. This is what the systems look like with the batteries inside. And this is what the systems look like from the back using the wall mounted hangers. Now, a really common use for the SRB4 cabinets is using these cabinets in conjunction when you have to stay under 20 kilowatt hours per cabinet and you need to keep these cabinets 3 feet apart. The ability to tie into the Luxpower inverter using both battery terminals makes paralleling these cabinets very simple. So in this situation, you could put up to four batteries on one cabinet, 4 batteries on the other cabinet. You can run communication through the conduit lines between both cabinets using shielded Cat5 cable. And then using the battery cables being the same length, you can parallel within the inverter and you can meet these requirements and offer up to 40 kilowatt hours of battery storage with only 11 inches, less than 11 inches coming off the wall. The last products I'll discuss are our off-grid battery systems. And this is really centered around the Luxpower SNA 6000 off-grid inverter. This is a UL 1741 certified inverter. It's a fantastic inverter with a lot of advanced features. You can connect up to 16 units in parallel. You still have closed loop communication with the SR5K UL batteries. There's Wi-Fi, there's 4G monitoring. It does have a grid input line, and grid energy only comes through the inverter to run loads or charge the batteries. There's no ability for this to export. It's not bidirectional. You can put up to 8K of DC coupled solar. There is a generator port. It does not have the ability to AC couple, but you can hook up a generator. It has dry contact auto start, and this has 6 kW of continuous output power. What really pairs well with the SNA 6000 is our brackets. The brackets allow for a very cost-effective way to stack and build up a battery bank while securing the batteries safely. Some of the advanced features that the brackets offer: no weight is sitting on the batteries. Through the design of the brackets, it's distributing the forces from bracket to bracket, and you're securing the batteries to the bracket using the rack mount holes in the front. The natural gap between the different brackets facilitates airflow. The brackets are made of galvanized steel. It's designed to support up to 8 batteries in terms of weight. The way that these secure and interconnect using these latches, you don't have to use any tools to secure these batteries. With each bracket, we send a cable kit that includes power cables, grounding, and communication cables. In addition to these brackets, we offer a combiner box. Inside the combiner box, we have positive and negative bus bars rated up to 1,000 amps, and there's connection points that allow for cables to come in from the back of the combiner box, and then through this, you can connect multiple inverters. You can do multiple stacks. You can parallel combiner box to combiner box, and you can expand your battery bank to 320 kilowatt hours if you really wanted to, and still maintain closed loop communication. Because the copper bus bars are 1,000 amps, that allows you to connect up to 6 units of the SNA 6000, which would be for 36 kW of combined power. If you wanted to use these units with the Luxpower 12K, that would be UL 9540 certified, and you would connect up to 3 units. So with that being said, thank you so much for watching this webinar presentation. I hope this was instructive and you learned more about our product lineup. We'd love to talk to you. If you have any questions, please feel free to reach out to us by phone or email. Have a great day.